Hello everybody and welcome to our video on the law of cosines. So let's jump straight into it. Theorem: the law of cosines states that in a triangle ABC with sides of length A, B, and C, a squared equals b squared plus c squared minus 2bc times cosine of the angle A. B squared equals a squared plus c squared minus 2ac times cosine of the angle B. C squared equals a squared plus b squared minus 2ab times cosine of the angle C. So a couple quick things here. The first thing is, notice that all of these look like the Pythagorean theorem, right? A squared equals b squared plus c squared minus something. So really, the way we can think of the Pythagorean theorem is as a special case of the law of cosines. The law of cosines is more powerful, more general. It can deal with triangles of all sorts, whereas the Pythagorean theorem can only deal with right triangles. So notice in particular, so we'll use this last case, if C was equal to 90 degrees, then we get C squared equals a squared plus b squared minus 2ab times cosine of 90, which is 0. So that part disappears, all right? So again, that's what I'm saying is the Pythagorean theorem is just a special case of this law of cosines. And another thing is that although we've written this law of cosines in 3 different ways, it's not too hard to remember all of the ways if you just realize that whatever side is on your left-hand side of your equation, so a squared, that's going to be the angle you plug into cosine, the corresponding angle to that side. And whatever you have here, b squared plus c squared, is going to be minus 2bc. Or a squared plus c squared, it's minus 2ac. Or a squared plus b squared, it's minus 2ab. Whatever the sides are that are part of your squared terms on the right are also going to be the same sides multiplying with cosine. So hopefully that helps make it a little bit easier to memorize this or to apply the different versions of it when it comes up in problems. Now, let's go ahead and take a look at a proof for the law of cosines. So this is really just one case. We've drawn one version of the types of triangles we can get. We're not going to do all the various iterations of this, so let's just take a look at this one. So here, what we've done is we've taken our triangle ABC, and we've broken it up into 2 right triangles. So we've dropped the perpendicular line from angle B down to this side. And we've said, okay, well, what do we know about this? Well, we know that sine of A equals my height here divided by C, right? So sine of A equals the height divided by C. So that height, if I multiply C across, is C times sine of A. And we know that this side here, maybe I could call this little b. Well, I shouldn't use little b because we've got b for the whole side length. So that would cause some confusion. I'll call it z here. This is z. So here, when I look at angle A here, I see that cosine of angle A is z over c. Adjacent over hypotenuse, multiply the c across, and z equals c times cosine of A. So what does that give me for this side here? Well, if the whole length is b, then this is just b minus c cosine of A. It's the part that's left over when you subtract this part in green. Okay, so with that all being said, if we look at this right triangle on the right now, we can apply the Pythagorean theorem and square our sides, so we get b minus c cosine of A squared plus c times sine of A squared equals A squared. And now we multiply everything out. When we multiply b minus c cosine of A squared, you get b squared minus 2bc cosine of A plus c squared cosine squared of A plus, And then c times sine of a squared is just c squared sine of a, sine squared of a equals a squared. Okay, so now what do we do? Well, now we just take the c squared cosine squared of a plus c squared sine squared of a. We factor out the c squared. Other than that, we've just rewritten everything else. And we know that cosine squared of a plus sine squared of a is 1. So we simplify this and we get b squared minus 2bc cosine of a plus c squared equals a squared. So all I'm doing here in the last step is just rewriting this into the more standard form, right? It's the same expression. I'm just reordering which way I add. We get a squared equals b squared plus c squared minus 2bc times cosine of a. All right, so that's one of our cases for the Pythagorean, or for the law of cosines, I should say. Now we're just going to go ahead and jump in and start applying this. Example 1, solve the triangle ABC. So A equals 12, B equals 9, and C equals 75 degrees. So if I'm using angle C, then I need to use the version that has little c squared on the other side. So that's c squared equals a squared plus b squared minus 2ab times cosine of c. Well, I'll just write it in terms of c to start. And now I start plugging everything in. So c squared equals 12 squared plus 9 squared minus 2 times 12 plus, times minus 2 times 12 times 9 times cosine of 75 degrees. That implies that c squared equals 144 plus 81 minus, let's see, this would be 2 times 12 is 24 times 9. All right, and I'm trying to simplify this as much as I can before I start rounding things in a calculator. So 2 times 12 times 9, it's going to be 216 times cosine of 75 degrees. So c squared equals 225 minus 216 times cosine of 75 degrees. And so now when I take the square root of both sides, I get c equals the square root of 225 minus 216 times cosine of 75 degrees. And again, I just waited until now to start plugging things into a calculator that have to be rounded so that I have as minimal of rounding errors as possible. So this gives me c as approximately 13.004. Okay, so that's side C, but now we also need to know our other angles. So I'll go ahead and just kind of separate that work here. Now, in order to solve our other angles, we could turn to the law of sines. That would be perfectly fine. But I do want to demonstrate that we can solve for those angles with the law of cosines if we know all of our sides already. So once we know all three sides, we can solve for angles using the law of cosines. So let's go ahead and take, we'll go for angle A here. So we'll use the form a squared equals b squared plus c squared minus 2bc times cosine of a. That gives me 144 equals 81 plus. And when I take the value for c here and plug it into a calculator and square it, I get approximately 169.1 minus 2 times b, which was 9, times c, which was roughly 13.004. times cosine of A. So now I'm going to subtract 81 and 169.1 from both sides of the equation. And let's see what we get. 144 minus 81 minus 169.1 gives me negative 106.1 equals, and now I've got this negative 2 times 9 times 13.004. That's negative 234.072 times cosine of A. So now if I divide that across, I get cosine of A equals roughly 0.453. And so that implies that A equals cosine inverse of 0.453, which is approximately what? Let's see. Calculator says 63.1 degrees. Okay, well that's great. That gives me my second angle. And of course, once I have two angles, I can always find my third angle by taking 180 degrees minus the other two angles. And that gives me approximately 41.9 degrees. Okay, let's go ahead and move on here. We'll tackle another example. So in the previous example, we had one angle and two sides, and now we're dealing with the case where we have three sides. So now we can solve for any angle we want, right? Like we know all three sides, we can pick any angle we want to solve for initially. So let's go ahead and solve for A. Why not? Okay, so we'll use A squared equals B squared plus C squared minus 2BC times cosine of A. A squared is 225, B squared is 64, and C squared is 81, minus 2BC. So 2 times 8 is 16. 16 times 9 is 144, times cosine of A. Now we're going to subtract the 64 and subtract the 81, and 225 minus 64 minus 81 is 80. So we get 80 equals negative 144 times cosine of A. I divide that negative 144, I get negative 80 over 144 equals cosine of A. And so A equals cosine inverse of negative 80 over 144. Let's see what the calculator says about that. Cosine inverse of negative 80 divided by 144. That's approximately 123.75 degrees. Well, that's one angle. Now, again, now that I know an angle, remember the law of sines requires that you know at least one angle. Now that I know one angle, I could use the law of sines, but again, I want to continue to demonstrate that we can solve for angles with the law of cosines, so we practice that skill as well. So in this case, I'll set it up for angle B. So we'll use B squared equals A squared plus C squared minus 2AC times cosine of B. So I get 64 equals 225 plus, let's see, where was I? C squared, that's 81, minus 2AC, 2 times A, that's 30, times 9, so that's going to be 270. Times cosine of B. First thing I'm going to do is subtract the 225 and the 81. So 64 minus 225 and minus 81. gives me negative 242 equals negative 270 times cosine of b. I divide out the negative 270, the negatives cancel. I get 242 over 270 is cosine of b. And that means that b equals cosine inverse of 242 over 270. And then it's calculator time. That gives me b is approximately 26.32 degrees. Well, if I've got those two values for my other angles, I can always find my third angle, of course, by subtracting them from 180. And this gives me approximately 29.93 degrees. All right, and all I was missing was my three angles, and now I found all of them, so I'm done. All right, now we're just going to touch on one more little topic here. This is Heron's formula for side-side-side triangles. Now, the proof of this formula is actually pretty cumbersome. Quite long, a lot of algebra. It's not complicated. It's not even conceptually difficult actually at all. It does involve law of cosines, but it's a little long to add into the video. So I'm going to go ahead and skip that. If you look for this proof, it's not hard to find. It's just a lot of algebra. That being said, the area K of a triangle with sides of lengths A, B, and C is given by K equals the square root of S times S minus A times S minus B times S minus C, where S is equal to 1/2 A plus B plus C, the semi-perimeter of the triangle, right? The perimeter is A plus B plus C. The semi-perimeter is just half of that. That's what that means. So, in other words, when is this valuable? This is valuable when all I know is the three sides of the triangle and I don't know the height of the triangle. So if you just know all three sides, you can go straight to this formula, plug it in, and be done. Now, I need to know what S is, so when we look at this example, find the area of the triangle using Heron's formula. We're given A equals 60, B equals 90, and C equals 140. So the semi-perimeter, that's 1/2 the sum of the three sides. That's 150 plus 140. That's going to be 290 over 2. That's 145. So my semi-perimeter is 145. And so my area K is 145 times 145 minus A, which is 60, times 145 minus B, which is 90, times 145 minus C, which is 140. Now I'll simplify this a bit first before I try to go plug it into a calculator. So 145 times, so 145 minus 60 is 85. 145 minus 90 is 55. 145 minus 140 is 5. All right, and so if I plug all that that's inside the square root into a calculator, what do I get? The square root of 3,389,375. And if I take that square root, what do I get? Approximately 1,841.03 square units. All right, and that's it for this video on the law of cosines. Thank you for watching.